simulation for optimal battery electric vehicle concept and operation strategies. Javier and Serv, are you there?
Hello, everyone. This is the use case C of the HIFI-ELEMENT project, which is related to component optimization. So in this use case, we are dealing with, let's say, problematic of creating an industry-like project environment. So for that, we will perform as we were just a vehicle manufacturer that wants to upgrade his currently existing EV. So for that, with the models that have been produced during the project, and we are going to set up a baseline vehicle based in the Iveco Daily, and taking advantage of the model architectures, parameter conventions, and model interfaces that has been developed in our project, we will do an optimization run. So in order to fulfill all of that areas, we have created an architecture, let's call it internal architecture in the use case, in which we are just firstly take the model from supplier, which are the models that develop in the project, do an optimization, and in order to be sure that our optimization is giving us correct results, we will set up a mill environment test and a real route and emission profile environment for testing as well. So what we first do is just to check that all of our interfaces and parameters conventions are correctly set. We create this robust baseline that allows us to have all the baseline parameters. And then we will be led into the situation in where we have up to 35 different component variants. So this will let us in just one step to start the optimization path. So in our optimization path, we have gone to a genetic algorithm in order to do the optimization. And since we normally know that this type of optimization take a lot of time, and they are like really computational effort consuming, we have decided to go with the multi-core environment in order to speed up our simulation capability. So this has allowed us to establish the typical result of a multi-objective optimization that led us to a Pareto front in which we can have, let's say, optimal result where our target, or first and important target, which is energy consumption reduction, can be matched to any other type of performance feature. So in our part, in the optimization part, we have seen results up to 12% reduction thanks to our optimization results. So once we have this optimized, let's say, vehicle, we can take our vehicle and easily export it thanks to the capabilities of the model interface to be tested to real route scenarios and traffic simulators, and we can quickly connect it to them. So that will allow us to evaluate the performance of our vehicle and check if our type of feature, for instance, speed recommendation controllers, can allow us to have even more reduction in consumption. So as well, we will move to a hill path, a hill environment path, in which we can start to test real route scenarios that can be compressed as city or mountain scenarios, and where we can take our optimized vehicle to be checked if we stress it out by doing brake, acceleration, and suddenly stops, just to check that the whole architecture is fully functional. Okay, so that's us more or less what to do with the whole activity of this use case that has allowed us to certify that we have a robust interface standard that allowed us to have plug-and-play models that facilitate the use of complex simulation environments. From another part, we can also, we were capable of proving that we can also mix optimization with other type of platform for real driver software. And finally, we have checked that with this architecture that we have, we are just one step away of doing any type of exil activities. So this is my presentation. So thank you. I will let to set up.
Okay, thank you very much. We have a question here from Willem. Which input parameters do you need to define an electrification package for an existing vehicle like you did there? Which input parameters do you need? Do you need the design of the original vehicle?
Well, yeah. In our case, Iveco Daily was one of the baseline vehicles of the project, and also we have Iveco in our project. So we knew their target, so we can reproduce the baseline. Okay,
I have a question. There's one more here from Alain and one from Florian. 1 second. You said you had a certain percentage of improvement in consumption.
Yeah.
But what happens if the driver doesn't follow your rules?
In that case, in the optimization part, he was kind of forced to follow my rules. So in case he's trying to openly drive, we are expecting that the improvements in the powertrain will have an impact as well.
So you'd need some kind of robustness check, wouldn't you, to check for people who don't follow the rules one way or the other?
Exactly. That was the purpose, actually, of having the mill test at the end. That 3D scenarios that you have seen, that allow you the possibility to do as you want in the driver environment, and checking that the improvement that you have got for the powertrain are feasible.
Okay, there's a question here from Florian. What kind of software did you use for real route scenario?
Yeah, in our case, we have previous experience for another project using Sumo, which is an open source traffic simulator.
Okay, we have a question as well from Alain. How do you select the model level of subsystems for the optimization design?
As I understand, he is referring to the component. We are using component level. Okay, so what we have is version of component. Let's say, for instance, I have 2 different batteries, 4 different high voltage DC-DC, so I am just selecting among them.
Okay. If I understand it, you had a Pareto front there, so there's an optimization algorithm behind it. There's a question here from Horst. How many parameters could you optimize simultaneously with the genetic optimization algorithm?
Yeah, it's really hard to answer that. I mean, we have been playing with the battery, the DC-DC, the inverter, the different type of motor, the reduction of this. We play with several of them. There were easily more than 10.
Is there a limit?
Well, it's the limit. The limit it will be put by your own computer, because as more input you put, that means that you need to make more simulations. So you will take more time.
Okay. Well, Javier, thank you very much for your contribution.